right. Hi, everyone. Welcome to AI for Architects. Super excited to have you all here. I think it's going to be a really amazing 7 weeks together. I'm Jacob Russo. I'm a senior computational design architect at SOM, where I'm involved in the development of computational and AI enhanced design tools and workflows. Before we dive in, I just want to say whether you're brand new to AI or you've been experimenting with tools for a while now, this course is really designed to meet you where you are and take your work and practice to the next level. We're going to move fast, develop real workflows, and have some fun along the way. I'm really excited. So parametric design is fundamentally about relationships, not fixed geometry. Instead of drawing a specific rectangle, for example, you define the logic creates rectangles based on parameters, so width, height, constraints. So when you change an input, maybe you have a sight boundary or setback distance. That's something we'll see in the demo. Then your logic automatically updates the output. So this is a key difference from traditional CAD. So there's some examples, like facade systems, structural optimization, space planning. In all these cases, with parametric design, you start to encode design intelligence into a system and then be able to explore variations far faster than manual modeling. So the key mindset shift is you're no longer really designing the exact specific final output in a way, but you're designing the system that then allows you to explore more options and design sort of more of the options around like your particular building. But so generative design is not equivalent to machine learning, right? So while machine learning analyzes and predicts, generative design actually creates and generates. So think of machine learning as a pattern finder and generative design as a creator. So generative design uses mathematical algorithms plus optimization, often using simulations, not machine learning. And it follows defined rules and constraints, produces validated performance-based solutions, and can exist without AI, just like Galapagos, which is quite a simple example. But we'll see that we can also enhance the analytical kind of aspects of our generative design workflows with AI tools, machine learning. So this is the story of Sidewalk Labs, Toronto, which is a smart city project, probably the most high profile failure in the smart city development, and really a lesson in what happens when ethics are overlooked. And these were actually, what ultimately led to the failure of the project. So first of all, ubiquitous data collection. Like if you just say that out loud, like that's, you can already tell, like that's no good, right? So sensors were planned for every home, street, and public space with no continuous monitoring of resident behavior and urban activity, not occasional monitoring. So this was continuous surveillance of everything. There were no surveillance-free zones, right? And there was not really the ability to opt out of that, right? Everything was being tracked, even in public spaces, or that, that was the proposal. It was unclear whether citizen data would be stored in Canada, subject to Canadian law, or in the US, right, subject to American surveillance laws and the Patriot Act. This would actually determine whether Canadian privacy protections would actually apply. So there was that uncertainty around data storage, facial recognition capabilities. So despite later promises not to use it, the infrastructure would have facial recognition capability built into it. And once the infrastructure exists, the temptation to use it, it's hard to overcome that, right? We won't use it is different from we can't use it. So this created pretty much an impossible consent situation. So how do you consent to being monitored when you can't opt out of using public spaces, right, like streets and parks? This is fundamentally different from consenting to like, Facebook's data collection. You can choose not to use Facebook or other social media, right? You can't choose not to use public streets, really. unless you just don't live there. But this was supposed to be a huge development. And lastly here, so how can we as architects learn from this? In terms of trust and engagement, right? So public trust is fundamental, and you can't use technical solutions to fix trust deficits. So we have to engage our communities. This has to be meaningful and not theater, not just performative. Transparency about AI use. This is what will actually build trust rather than erode it. So we need to maintain a democratic process, right? Cities aren't corporate R&D labs. There needs to be clear accountability structures before deploying. Some of you folks may be actually working on larger scale projects, right? This can inform how you approach them with technology um, goals. And privacy by design is, it has to mean it's mandatory. It's not optional. So we have to have the regulatory frameworks in place before deployment. And we have to have the consent mechanisms that can be actually practically achievable. So we're going to use the distribute to grid component, which is a nifty tool that they added from, this wasn't in previous versions, but what this does is essentially what you see here. It distributes uh, the solutions that we've exported to a grid. So all you need to do is bring your fitness values into fitness values, the data into data, and the phenotypes into phenotypes. And we'll talk about what all these mean. But then you just have the size of the grid in the X and Y and the size of the text. Right. And so what we're seeing here is a neatly organized grid of our exported solutions. It tells us the number of exported solutions, 20 out of 400. And it's telling us the generation and the individual. It's giving us the fitness values. And it's also giving us the data input that we put in here, right? So our GFA for one and our open space area for two. So we can actually start to say, right, like these are some of the most optimal solutions. We can do further analysis, right? We can use our diamond fitness chart and we can export specific solutions, but you can see how the GFA is quite optimized. We go to plan as well. We can see that open space is quite minimal. And then the diversity of the skyline, it seems like it did a pretty good job there too. Just before we jump into the demo is, a couple examples of how this actually integrates into real architectural practice. Like what problems should you tackle? Like what are some examples out there? So there's a few, but floor plan layouts is one interesting and good starting point. So space allocation with adjacency requirements and being able to kind of like encode rules about which programs need to be near each other, optimizing for like circulation and egress paths. Um, these are things that definitely lend themselves to parametric and also AI assisted parametric design. Um, so there's a particular example here from actually one plugin that's available on Food for Rhino. It's called Magnetizing Floor Plan Generator. It's an open source Grasshopper plugin from the Bauhaus University in Germany. So this demonstrates that these workflows are sort of like more proven and production ready. So you can start to experiment with some of those and also use them as a jumping off point to create some custom solutions. So if we have like this base plan, right, and our goals are to create like circulation, first of all, and then a unit mix, right? So we can actually start to do that pretty quickly. So we can just click on the floor plan here, and you can see this pop down. So we can already start to generate unit mixing corridors. One thing to note is that up here, in order to do that, we do need some center lines. So if we click on that, you can see that I've already drawn a center line. So you can just take a line here, and this is just going to allow for the algorithm to run our corridor analysis generation. And so this can be a bit more nuanced, but for now we'll just do a simple like center line here where we're just going to indicate where we want our corridor essentially. Okay, so I'm going to go back here and I'm going to just do generate unit mixing corridors. Cool. So you can see that the algorithm has already started, and kind of similar to like what we were learning about in the Wallasey class in generative design, it's optimizing, using its proprietary algorithms, but a combination of AI and generative design algorithms going through several iterations. This is quite fast. And you can see here on the left side, we have a few different filter options. So we can say how many stairwells we want. So if we want potentially 1 to 3, let's just say 4, for example, right? So this is, maybe giving us options where we'd have more. But in this instance, I mean, let's see what happens if we do full ones. It's kind of smart enough to realize that we only need about 2. Thank you all for being here, and enjoy the rest of your evening. And we'll see you tomorrow at the same time for our first class.